ton of refrigeration. The rate of heat transfer that results if you wanted to freeze 1 short ton or 2,000 pounds of pure water at 32 degrees F in a time period of 24 hours. That's really the basic definition. So you go from saturated liquid at 32 F to saturated solid frozen ice at 32 F. We have asked this clicker question. I'm not going to ask it again, or should I? Okay, ask it again. Fine. So anyway, it's a rate of cooling. That should be closer to 100% correct. All right, so you need to know the latent heat of fusion. That's like HFG. Now that's going from saturated liquid to saturated vapor. You need to know the latent heat of fusion going from saturated liquid to saturated solid or ice or something like that. You know, different syntax, different subscript, but it's as similar as latent heat of boiling or vaporization. But here it's freezing. Okay, it's about 144 BTUs per pound or 334 kilojoules per kilogram. Well, you can do this. You could say 1 ton of refrigeration equals how many BTUs per minute of cooling. We know that is the right answer from your experience, but how would you calculate it? Well, you'd say Q dot is equal to some sort of mass, and then that enthalpy of fusion or melting or solidification, and this gives me amount of energy, but it was per how long? It was per a 24-hour time period, a delta T of a day. And so you just put in your numbers. You say, well, it's 2,000 pounds. Wasn't that the mass of interest? 144 BTUs per pound. And then you divide by 24 hours. But you want it in BTUs per minute, so an hour is 60 minutes per hour. And it works. And you'll get then the 200 BTUs per minute, and you can convert that to 211. Somebody in the 830 said, well, you give us that on an equation sheet. I still want you to know how to reproduce and the things that are on the equation sheet like that. Does that make sense? Anyway, I thought that was so important that on the last day of refrigeration, what did we go back and talk about? A ton of refrigeration.